Now we're going to look at the major cellular activity that immune cells do in the innate immune system other than releasing molecules, and that is phagocytosis. And this is critical to the entire immune system. This is often where an immune response will start. It is often what happens long before the adaptive immune system can get going, and it can lead to triggering the adaptive immune system. So let's get into it. So this is how we typically draw phagocytosis. Phagocytosis is a type of endocytosis. It's a vesicular transport. It's how cells bring large objects into themselves. It's something our own cells can do. Bacteria can never do it. So we start with a macrophage. This is a common type of cell that would do it, and it wraps its membrane around the bacterium, and that leads to a vesicle inside a cell called a phagosome. And then the cell can combine that phagosome with lysosomes, which release digestive enzymes and break down whatever the cell ate. And then it can be released as debris. And macrophages do this for all sorts of reasons. I want to show you some videos of this because you may or may not be able to get it from that. So this one is a famous video from McGraw-Hill, and they just animate it a little bit better. So there you see the cell is wrapping its membrane around the bacterium as they list different types of endocytosis. We will look at all of those in this course, and then eventually pop. So just think of a cell membrane and a vesicular membrane as like the stuff you use to blow soap bubbles. They can combine into one bubble, and if you bend them the right way, they become two bubbles, and that's kind of what happened here. So now you have a bacterium in a vesicle. And this video shows what comes next. So again, you have a cell with a nucleus and a bacterium in a vesicle, but this video also shows lysosomes, small vesicles full of digestive enzymes. And this video will show the cell will bring lysosomes over, and they will fuse and digest the bacterium. So that's what phagocytosis looks like, and it's very nice that the textbook companies let people post their videos on YouTube. So there are two major reasons cells do phagocytosis. One of them is to take up material and kill it, or just digest it for recycling. So macrophages will recycle cell debris in our tissues to clean our tissues, and they'll take dead cells and turn them into raw materials that other cells can use to build new things. They'll also use it to kill bacteria. So if they find bacteria, they use phagocytosis to kill them. That's one major purpose of phagocytosis. The other is to bring in antigens that can later be presented to adaptive immune cells, specifically T cells. T cells are a critical part of the adaptive immune system, and they can only see the world when antigens are presented to them. That's the only way they can see anything. And so a cell like a macrophage can do phagocytosis to bring in an antigen and chew it up and present part of it to a T cell. And that's going to be a major, major part of the adaptive immune system, as we will see. So this again is how we mostly kill bacteria. This is the best way for killing bacteria. There are a few others that we will also see later. This is a slide that goes through ways that real pathogens evade this. So if you want, feel free to pause it here and read through it if you're curious, but otherwise we can skip it. It just shows that at every step of the process, various different pathogens have found ways to get around it. Alright, so the next video we will look at innate immune cells and what they do. I'll see you there.